Hello, my math friends. This is Mrs. Schlecht, and in this video, we are going to subtract some expressions. All right, my friends, so you know that before we get started, there's a few materials you need in order to be successful for this activity. First, you're going to need your Envision book. We're still in volume 1. Second, you're going to need that math notebook so you can take those great notes and keep track of all that great math thinking. Third, you're going to need your pencil. And fourth, last but certainly never least, that positive math attitude. All right, my friends, so this lesson goes very well with lesson 4-7 in your Envision book. The key concepts for this lesson can be found on page 242. Now, if you check out that key concepts page, it might look a little overwhelming at first, but can I tell you something? It's all about opposites. I'll show you what I mean. All right, my friends, so this example is actually from the Key Concepts page 242. And if you remember, last week we talked about adding expressions. And it was really similar to like simplifying expressions. But remember adding, it's just so easy and nice, right? Now, if you look on that Key Concepts page, all of a sudden it starts talking about the distributive property. What it's trying to get you to do is, if we multiply the things that we have in the parentheses by a -1, what we're doing is we're actually just changing all of our signs to whatever the opposite sign would be. And then, my friends, the most important, most beautiful part of the whole distributive property with a -1 is that this subtraction sign will turn into addition, and then we're just adding. How awesome is that? Let's look at this a little more. So we're still going to keep 5. 5 is just going to stay the same. It's going to be a constant, my friend. All right, so the first portion, just going to stay the same. But now we're adding it with that -1. And we're going to distribute or pass around that -1 to whatever is inside my parentheses. So if we have a minus sign, but then I multiply it by a -1, that is what changed it to addition, all right? Now, if I take a -1 and I multiply it by a -2x, how would I represent that? Well, instead of subtracting 2x, I would now be adding 2x, because remember, when you multiply a negative with a negative, it turns into actually a positive number. How do we represent that? By saying that we're going to be adding 2x instead of subtracting 2x like we did in our original problem. Now let's look at this -7. Now remember, if we're multiplying it first by that -1, we're still going to have the value of 7, but it's this sign right here that's going to be the opposite. So what's the opposite of subtracting 7? Adding 7. So my friends, what we have done is we've distributed this -1 to the value that was inside the parentheses. Now again, we did not change the value. The only thing we did was change the look of it so that we can actually solve this. So now I'm wondering, well, how can I rewrite this expression to show that we're adding our terms? So my friends, what we did is we went from a subtraction problem to an addition problem. But remember, since we distributed that -1, we have not changed the value at all. And I bet you're thinking, hey, Mrs. Schlecht, there's some like terms that you can combine. And you're right. So how could a simplified version of this expression look? So we could rewrite this expression as 2x plus 12. Now, how awesome is this? We have written 3 different expressions, but they are all equivalent. Remember, we changed the look, but we never changed the value. Now let's look at some more examples from your book. So the first example that we're going to look over together is on page 242, and it's number 4a. So we have 21x minus a -16 plus 7x. But what we're going to do is we're going to use that distributive property with -1 to make all of this the opposite. Now remember, we're not going to do anything with this 21x. That's just going to stay the same. But when we multiply the rest of this, when we distribute that -1 to the rest of our expression, this is going to become addition. This will become just a positive 16. And then the opposite of addition is going to be subtraction. So this is what it will look like when we've distributed that negative 1. So once we have distributed that negative 1, we'll have 21x plus 16 minus 7x. Now again, remember my friends, we never changed the value at all. All we did was we changed the look of it. We used that distributive property to pass around that negative 1 so that I could change these operation signs. Now, do you see some like terms? Any simplifying that we can do? So I was able to combine the 21x and I subtracted 7x from that, and that's how I got 14x. And then so sad for our positive 16. Yes, it's positive, but it does not have a buddy. So then we're just going to bring it down. So now our final expression in a simplified format is 14x plus 16. Again, my friends, we have never, ever changed the value between these three expressions. All we've done is we've changed the look of it, so now we can solve it. All right, so now we're still going to stay on page 242, and we're looking at number 4 still, but now part B. So in this expression, we have negative 13n minus 17 minus 5n. Now remember, when we distribute that negative 1 to start changing our signs, we do not do it with where we start from. So this negative 13n is going to stay negative 13n. So this negative 13 is going to stay negative 13. But when we distribute that negative 1 to the second set of parentheses, what it's going to do is change our subtraction sign to addition, change our positive 17 to a negative 17, and then change our subtracting 5n to adding 5n. So now this is what our new expression will look like. So our new expression, negative 13n plus a negative 17 plus 5n. Now, do you see some like terms, my friends? Now let's start combining them. So our two like terms in this expression, negative 13n plus 5n. And remember, when you add a positive and a negative number together, you take the sign from the absolute value that was the highest. So in this case, 13, the absolute value of 13 is bigger than the absolute value of 5. Therefore, we're going to keep whatever sign 13 had, which just happens to be negative. So when we take negative 13 and we add a positive 5, our answer is going to leave us with negative 8n. And then this negative 17 is just going to stay negative 17. Again, my friends, 3 different expressions, same value. Next, still on page 242, still on problem number 4, but now part C. So we start with these two parentheses, 4y minus 7 minus y minus 7. So do you know what it will look like once we've distributed that negative 1 throughout this second set of parentheses? So once we've distributed that negative 1, we'll have 4y minus 7 plus negative y plus 7. Now, do you see some like terms that we can start combining? So first, when we check out our y's, we have a positive 4y here, and then we have a negative y here. That's just like taking one of those y's away. So we're left with only 3 y's. Now, look at this negative 7 plus a positive 7. Do you remember what happens when you add those integers that are opposites? It just gives you 0. So my friends, this expression right here, just 3y, is actually the simplified version of all of these expressions. Again, different look, but same value. All right, my friends, so the last problem that I'd like to look at together is still on page 242, and it's number 4D. So we start with negative w plus 4/10 minus negative w minus 4/10. So remember, we're first going to start by distributing that negative 1 to the second set of parentheses because that will turn it to an addition problem. But remember, it's also going to make these two signs the opposite. So our next expression that will be equivalent to this after we've done all that distributing will look like, remember, that distributive property is like super great, but it only works with that last set of parentheses or set of terms, that last expression, right? The first part is just gonna stay the same. So we still have a negative w plus 4/10, but now we have plus w plus 4/10. Now check out our W's. We have a negative W and then we're adding a positive W. And just like we talked about with the number 7 in that last example, when you have a negative number and then you add its positive twin, its positive counterpart, that just cancels each other out. So guess what? We're done with variables in this expression, but we can still add these like terms. So the final simplified version of this expression would look like just 8/10. That's it. Because remember, a negative W and then you add a positive W just cancels each other out. Again, my friends, we never change the value of any of these expressions. We've just changed the look of it so that our smart math brains can actually figure it out. All right, my friends, that was just a quick run through over lesson 4-7 in your Envision book. And as always, if you have any other questions, please let me know.